Hello everyone, it's Bill again at Energy Independent Solutions. I wanted to take this time to do the video today of my EV charger that I put out, and I'm kind of doing this video for one person who wants to build it himself, but he said he wanted some pictures and I think the video would do him a little bit better. So basically all my charger is a capacitive charging system. That just means that as long as you stack enough capacitors on the line side, which is the main voltage side, you can build the charger to output as many amps as you like. If you want 20 amps or 30 amps, you just have to put enough capacitors in there to handle the load. As far as the capacitive charging works, the way you calculate how much charging current you're going to have, a good rule of thumb is using a 25 microfarad capacitor will output 1 amp of power. So for every 25 microfarads you'll get 1 amp. So if you have a 100 microfarad run capacitor, which is what we'll be using for my charger, then that's a 4 amp output on that charger. So if you bank those together and parallel them, you can build the charger as big as you like. So here's just the chargers that I've had, the capacitors that I have around the house. I've paralleled them all together, put my lead on it. I have put my bridge rectifier on it so that it is just the basic charging system, and from there the person that builds it can do whatever they want. I have a cutoff circuit that I build into the system that will cut it off at full charge voltage, whatever the pack voltage is. So take a look at it, tell me what you think. I'm going to detail exactly what I've done here so that you can see it and know that it works. We'll plug it in and we'll show that it's actually receiving DC voltage, and I'll explain how it works a little bit better after the video. Okay, pardon my my messy work table here. Now, as you can see, I've got the 100 UF 100 microfarad run capacitor right here, and I've also got a bank of other capacitors. These are like 5s. I think this is 15 and these are 25s. So altogether I think I should have about 10 amps of charging current here. These are just capacitors that I had laying around the house. Now I just want to show you how to do it. Here I have my cord to plug in. There you go, see, 110 volt cord. The other end of it is right here on the capacitor. You see the capacitor right here. Basically all I did is I plugged it onto the stake-on of the capacitor. I kept the neutral wire and ran the neutral wire all the way to my bridge rectifier. We'll get to that in a minute. Then I came off of the other side of the capacitor. Right now they're not charged, so I can touch them. I came off the other side of the capacitor and down to this one, and then I went from one side all the way down. As you can see, I went same side all the way down, and then I paralleled on this side right here all the way down, just like that, so that each side has a wire on it. Now at the end of this side, as you can tell, I've taken a wire out. So basically what's happening here is we're feeding power in, then we're feeding power through the capacitor, back out of the capacitor to this capacitor. Now what's happening is we're feeding power through this capacitor and out this side of the capacitor. And then we've just added another one, and we're feeding out, we're feeding in and out, and then in and out, and in and out, and in and out, and in and out. So this side will be power coming in, this side is power coming out, right here, all the way down. So on my power coming out side, I have hooked that to the part of my bridge rectifier here. You can't really see it too well because of the dim light, but on the bridge rectifier you'll see a positive and a squiggly line. The squiggly line is AC. Now these connectors, these stake-ons on here, are a bit different because they're diagonal from each other. See, if you can look at this and see I've come off this capacitor to my squiggly line post, and then diagonal from it is where I've attached my neutral. Now the same holds true for the DC side. So the positive, which will come out DC right here, this will be my DC positive, and this one diagonal here will be my DC negative. So whenever I plug this in, you'll have negative and positive, and it'll be negative and positive at 120 volts, or whatever your mains voltage is. Now, don't panic about the 120 volts, because here's what's going to happen. Once you hook this up to the battery, to your battery pack, you cannot hook this charger up to a 12 volt battery because it will fry it. However, if your battery pack is 72 volts or 84 volts or 120 volts or 144 volts, you can hook this straight to it, and it will drop the voltage to whatever pack voltage is. So I'm going to be using it for my car, which is going to be 72 volts, and you just plug it straight off of the positive and negative terminals from the bridge rectifier to your positive and negative on your battery pack, and it will charge at 72 volts and give you however many capacitors worth of amps you have. If you have one capacitor, it'll give you, if you have one capacitor that's 100 microfarads, it'll give you 4 amps of charging current. So if you have 4 of them, it's going to give you 20 amps of charging current, or thereabouts 20 amps. That's going to give you 18 amps, and then you'll get 20 amps with 5 of them. So close enough. 5 of them will give you 100 amps. I'll give you 20 amps of charging current. Pardon me, I'm getting ahead of myself. Alright, now that's the charger. Now I don't have my cutoff circuit available to show, but I do have the circuit diagram of the cutoff circuit, and I have PCB boards available, so that all you have to do is solder the components to the PCB board, and it comes with the wiring diagram. Basically what will happen is it will connect from the positive lead here. You will take this positive lead, the positive DC right there, you'll take that lead and you will go to a 30 amp relay, and then the other end of the 30 amp relay you'll take to your battery pack, and the negative side, the DC negative side, which is right here, will go straight to the battery pack. You just clip that on any way you can. Then at the relay here, what you will do is you will take the wires from your PCB board, and you will tie that to the cutoff circuit, and what will happen is it will monitor the battery pack, and once the battery pack reaches full charge, it will cut the whole system off, so you don't have to do anything. Now I also wanted to just show a little bit about my motor controller kits. I was throwing one together here for someone who ordered one, so this is kind of just a loose fit, but just to get the general ideas of how easy this is going to be. I've got one sitting here that's pretty loose with everything on it. Now when you order the kit, it's going to come with detailed instructions with pictures and everything, but I just wanted to show this in here since I have it sitting on the table right now. So here we go. Here's my motor controller. Now there's the controller. It's kind of just, if you can see, it's kind of just loose fit on there. I don't have all the bolts in it or anything yet, but basically what you see is I have 600 amp IGBTs. Get off there. I have two 600 amp IGBTs, which will give you 600 amps of current. When you parallel them together, it's 1200 amps, but I limit the current to 6 with my control board. Now, the other two are IGBTs also, but I use them backwards so I can use the diodes. So they're connected from here to here, so that they can be freewheel diodes. And then I have one 250 volt 12,000 UF capacitor that goes in there, and basically that's the circuit. Now I do have one more thing here to show, which is my printed circuit board. This is my printed circuit board that will fit right on top, and it's actually going to fit like this. it's going to go just like that, and all the components will be on here, and right here will be where you will solder your gate resistors that go to each of these terminals here on the motor controller. And that's it, guys. That's all you have to do to make this work. Now this board will have some settings on it so that you can up the current limit if you want to, or you know, if you want to set the current limit, you can do that, or if you want to change the frequency on it, you can also do that. So it will go up to about 25 kilohertz. So you can set it all the way up to 25 kilohertz if you want. It doesn't hurt it at all. I didn't do a set frequency. I wanted the adjustable frequency just because different motors have different frequency values. So sometimes at 15 kilohertz you can get the whine like the old Curtis controllers used to do, depending on what motor they were hooked to. So this way it gives you a little bit more option to tune out that whine. Well, that's what I've got here, and if you have any other questions or want anything else, you can always look me up on my website. Website's www.energysolution2day.com. Thanks for watching, and you can comment on YouTube. Thank you. Bye.